I'm a fourth-year computer engineering student here at the Rochester Institute of Technology, and today I'm going to demonstrate a small circuit I built. Back in the fall, I took a course in interfacing with digital electronics, specifically interfacing digital electronics with analog electronics. The capstone project for that course is what I'm about to show you right here. This is a heartbeat monitor circuit. So the way it works is start with this infrared sensor, and it senses distance. It throws IR light, infrared light, out of one side, and it receives infrared light on the other side and produces a voltage. So depending on how much comes back, we get a certain level of voltage, and that'll tell us how far away an object is. A lot of analog sensors are based on turning something in the real world into a certain level of voltage. The signal comes into this three-stage circuit I have set up here. The first stage is it's an amplifier, but it's more of a buffer. It amplifies by a factor of 1, but the idea is to sort of protect the signal from the rest of the circuit. You don't want to load it too much. So once it passes through that, it goes on to the second stage, which is a filter. The signal coming out of the IR sensor is so small that we actually get overridden by electrical interference coming from the lights, the wall outlet, generally the power grid. And when you have more noise than you have signal, you can't do anything useful with the signal. And in this case, we have a lot more noise. But we take advantage of the fact that that signal is coming in at a fixed frequency, 60 hertz. And we know that the signal we want is coming in at less than 3 hertz. So we filter out anything above 10 hertz using this filter. Then we pass through an amplifier. The amplifier gives us a gain of 220, and that gives us a signal we can read up here on the oscilloscope. Now there are two more stages to the circuit that we're not using right now. They're used for digitizing the circuit. This one is a level shifter, and this one does some other things with the signal so we can get it at the range and position we want to go into a microprocessor. We're not going to use that here because it's not as interesting in my opinion, so now I will demonstrate its operation. So I'm going to place my thumb over the sensor, and when I do that, the sensor is going to start responding to how the blood vessels in my thumb get thicker or thinner when my heart beats. And so the signal is going to correspond to how hard my heart is beating. So, hope I don't get demonstration syndrome. Yeah. So you can see the signal coming out right there. And if I pause this and then I stretch out the scale, yeah, quite nice. So you can see a large peak for the hard beat of your heart, because your heart does a 2-beat cycle. It goes a glub, 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 or a lub dub, or whatever you want to call it. So you have the high peak and the low peak. And then in between we have little valleys. And if I can get the cursor set up, maybe not. Sorry, vertical bars. There we go. Yeah, bring them into range. And so I can set one cursor to be set up over the peak of one cycle, and then I can select the other cursor and move it over the other cycle. And there is a horizontal distance between them of 584 milliseconds, or half a second. So I'm, 0.6 seconds. So I'm running a little over 60 beats per minute, actually approaching 100 beats per minute. So that's how we know it's working, because I have a slightly elevated heart rate. So there's my analog heart rate signal. If you have any questions, leave them in the comments. Thanks.